Welcome to the deep dive. You came to us with a pretty big task, actually.
Mm-hmm.
Synthesizing the essential knowledge from, well, a really comprehensive guide on building a successful data strategy.
Yeah, quite the undertaking.
So we've really dug in, extracted the core insights, and distilled them down into what we think is a solid strategic roadmap.
The idea is to give you that immediate understanding you need, to start thinking about transforming your own organization.
Exactly.
And look, that's our mission today, right? We're trying to move past the glossy vendor decks, the technology hype.
That noise.
Yeah, exactly. Our focus is strictly on the strategic stuff, the organizational, the cultural components, the things you need to actually move data from being, well, just a cost center
Right.
to something that provides sustained, measurable competitive advantage.
And we absolutely have to start with the core premise, the thing that drives this whole effort. It's what the research calls the data paradox.
Yes.
It's the fundamental problem for pretty much every modern company right now.
It really is. Organizations are quite literally drowning in data.
Terabytes, petabytes.
Exactly, just swimming in it. Yet, at the same time, they're starving for usable insights.
Oh.
Starving.
It's an incredible contradiction, isn't it?
It really is, especially in today's economy. Businesses are collecting mountains of information every single day. Sensor logs, customer clicks, website visits, operational data, you name it.
Everything's generating data.
Everything. But then, when leadership asks basic foundational questions about the business...
Like, how are we doing on X?
Precisely. The answers are often delayed or they're conflicting depending on who you ask, or sometimes they just don't exist. The data's there, but you can't get the answer.
And the cost of that
Yeah.
kind of intellectual paralysis, it's huge.
Oh, absolutely.
This isn't just, a minor inconvenience. The financial drain is genuinely staggering. The source material has some, frankly, terrifying anecdotes that really drive this home.
Yeah, they do. Think about that huge multinational retailer they mentioned. They discovered that their separate operational divisions, big parts of the company,
Yeah.
had been using 3 different ways to calculate inventory turnover
For how long?
for over 5 years.
Wow.
Because they were measuring this absolutely critical metric inconsistently, well, they were making major decisions based on totally faulty assumptions.
Which led to?
Millions of dollars in misallocated capital, massive stock inefficiencies,
Yeah.
just pouring money down the drain because the data wasn't trustworthy or consistent.
Or think about the complexity, the danger even in highly regulated fields, like healthcare.
Right. You mentioned the healthcare provider.
Yeah, the one where patient records were scattered across, 17 separate systems.
17 legacy systems, none of them talking to each other.
Imagine trying to get a single accurate view of a patient's history for diagnosis or even just for a compliance audit.
It was almost impossible. The data existed technically, but strategically, it was useless, locked away in silos.
And if we step back from the specific stories and just look at the numbers, the overall financial hit,
Yeah, the argument becomes pretty undeniable.
the research is really clear on this. Poor data quality alone.
Yeah.
Just the mistakes, the duplicates, the missing info
Basic stuff.
cost organizations, on average, somewhere between 15 and 25% of their total revenue.
15 to 25%. Think about that.
It's mind-boggling.
That's money just being flushed away cleaning up messes before you can even start thinking about generating value from the data.
So yeah, if data strategy is about survival, about competing effectively,
Mm-hmm.
you absolutely have to fix that foundational quality issue first. There's no way around it.
Absolutely.
So, okay, if the paradox is the problem, then the solution, and really our goal for this deep dive, is understanding how to move past just, buying the latest shiny tech platform
Right.
and actually embedding strategic data capabilities deep into the organization's DNA, the culture, the processes, everything.
That's the core challenge.
Okay, so let's unpack this really crucial distinction first. We hear these terms thrown around all the time. IT strategy, digital transformation, data strategy, sometimes almost interchangeably.
Yes, very common.
But the research is really firm on this. Mixing these up is basically the fastest way to fail. So what are the key differences we need to grasp?
It is absolutely critical not to conflate them. So, look, IT strategy that's focused entirely on the infrastructure.
Right.
the plumbing, right?
Servers, networks.
Servers, networks, the applications, making sure the lights stay on, basically.
Yeah.
Then you have digital transformation. That's more about changing the fundamental business model.
How you sell, how you interact with customers.
Exactly. How you engage with customers, maybe launching new digital products. It's often enabled by technology, but it's fundamentally a business model shift.
Okay.
Data strategy, though, is laser-focused purely on the data asset itself. How do you acquire it? How do you govern it? How do you keep it secure? And most importantly, how do you use it to create measurable business outcomes?
Got it. So if the IT strategy says, we're moving to cloud provider X, and digital transformation says, we need an e-commerce site, the data strategy asks.
The data strategy asks, okay, what specific information do we need to collect from that e-commerce site? How do we make absolutely sure it's accurate and trustworthy? And who gets to use it and for what? It starts with the data's purpose.
Right.
Exactly. So a successful data strategy doesn't kick off with, which cool new tool should we buy? No. It starts with fundamental business questions. The authors hammer this home. A true data strategy has to answer 4 critical questions, and importantly, all 4 are non-technical. They're business imperatives.
Okay, lay those out for us. Starting with, I guess, what data matters most? Prioritization.
First, what data do we actually need? And the emphasis is on need. This is about ruthless prioritization.
Not just collecting everything.
No, that's a common trap. If we collect everything, we'll eventually find something useful. The sources argue the exact opposite. You must focus intensely on the data that directly impacts your key performance indicators, your strategic goals. This focus prevents you from creating these massive, unmanageable, costly data lakes full of
Wow.
junk.
That immediately shifts the conversation, doesn't it? It's not an engineering problem of can we store it? It's a business valuation problem of should we store it? What's the value?
Precisely. Prioritize based on strategic value, not just collection capacity. Okay, second question. How do we ensure it's trustworthy?
Ah, the trust factor.
Crucial.
Absolutely crucial. This covers governance, quality, security, lineage, knowing where the data came from. Think about it. If your data scientists are spending 80% of their time just cleaning the data because nobody trusts the source,
Which happens all the time.
all the time, then you have a strategic failure on your hands, not a technical one. Trust has to be designed in, baked in from the start. And that requires executive ownership, not just, IT running some cleanup scripts.
Okay, number 3, making it useful.
How do we extract value from it? This demands clear, specific, high-value business use cases. You don't greenlight a big generative AI project just because it's the hot new tech.
You greenlight it because, say, it can automate the creation of 20% of your customer support knowledge base articles, directly reducing your service delivery costs by X amount. The potential value has to come before the technology choice.
Makes sense. And the last one, making it stick.
Number 4, how do we build the capabilities to sustain this long term? This is all about the people, the organizational structure, the culture, the processes.
The human element.
Exactly. You could have the best, most expensive platform in the world, but it will just gather digital dust, become shelfware, if you haven't invested in the human and cultural capacity to actually adopt it, maintain it, and iterate on it.
Yeah, that strategy-first approach is just perfectly illustrated by that anecdote in the research. The tale of 2 companies. It really shows how budget and fancy tech often take a backseat to focused strategic execution.
Oh, it's the ultimate cautionary tale, isn't it? And also a blueprint for how to do it right. Let's look at Company A first. This was a major financial services firm. They decided their data problem needed, well, a big checkbook and lots of tech.
The common approach.
Right. They invested $20 million, state-of-the-art data lake platform, hired a big team of very expensive specialized data scientists, and then they basically sat back and waited for the magic insights to appear.
Sounds impressive on paper, though. Big commitment, top talent, cutting-edge technology. You'd think that would work.
You would think, but 3 years later, total disaster.
Really?
Yeah. The data lake was full, petabytes of raw, completely ungoverned data that no business unit actually trusted. The data scientists spent all their time arguing over basic definitions like, what is a customer? Or how do we define revenue consistently?
Oh, wow.
Most of them got incredibly frustrated and just left. The result, a $20 million data swamp. It was a successful technological deployment, sure, but a catastrophic strategic failure.
Okay, so contrast that with Company B, smaller competitor, right?
Right.
Started with basically no budget, but a very different philosophy.
Completely different. Company B's approach was incremental, strategy-driven, laser-focused on value. They didn't start by trying to build a massive data lake. No.
What did they do?
They started by identifying one single critical business bottleneck. In their case, it was reducing the time it took to provision a specific complex product for a really high-value client segment.
A very specific problem.
Very specific. They put together a small, cross-functional team, business folks, IT folks, analysts. They cleaned and unified only the data they absolutely needed for that one task, nothing more. And they implemented some pretty simple descriptive analytics just to track their progress.
And the immediate result of that focused, narrow approach.
An immediate, measurable 30% reduction in that provisioning time. Tangible value right away.
30% is significant.
Hugely significant. But here's the really smart part of their strategy. They didn't just stop there and declare victory. They used the success, the credibility, the savings from that first win to fund the next incremental win.
Building momentum.
Exactly. And then the next one after that. 3 years later, they had successfully tackled 12 high-value use cases. They'd built sustainable internal capabilities along the way. And, maybe most importantly, they'd actually established a data-driven culture. Why? Because people saw direct, tangible proof that using clean, reliable data actually improved their jobs and boosted the company's bottom line.
That does raise an interesting point, though. When your company B pitching this incremental strategy to the executive team. And meanwhile, your competitors, maybe like Company A, are talking about massive, fast, big bang tech transformations.
How do you keep that executive support? Isn't there a risk they see you as moving too slowly?
That's a really critical point, and it's a trade-off that successful data leaders have to manage constantly. You maintain that executive support by ensuring two key things consistently happen.
Better.
First, absolute transparency. Every single one of those small wins, however minor it might seem, has to be immediately and quantifiably communicated upwards, and always in clear business terms: cost saved, time reduced, risk mitigated, no tech jargon. Got it. Communicate value constantly.
Constantly. Second, those small wins can't be random. They need to be strategically sequenced. They have to visibly link together, demonstrating progress along a clear capability roadmap. Company B wasn't just fixing 12 unrelated problems. They were methodically building foundational trust and capability. That allowed them to eventually tackle the bigger, more strategic challenges, but only after they had earned the internal capability and, crucially, the political capital to do so.
So deliver value early, communicate it clearly, and show how the small steps build towards the bigger picture.
That's the essence of it. It builds confidence and patience for the longer journey.
Okay, that focus on strategic execution, on delivering value, brings us neatly to the formal framework the authors propose. They argue that all successful data strategies really rest on 5 interconnected pillars.
That's right. And the key word is interconnected.
If you neglect even one of them.
The whole thing becomes structurally unsound. It struggles or it fails.
Right. So let's dive into these pillar by pillar. Starting with the one that, let's be honest, often generates the most groans, the most resistance: governance and quality.
Yeah, pillar 1, data governance and quality. And the first thing the research stresses is that leaders have got to stop seeing governance as just red tape or bureaucracy.
The Department of No.
Exactly. That mindset kills it. It needs a complete reframe. Think of governance as the operating system for data. It's not primarily about saying no. It's about establishing the essential rules of the road. Who's accountable for what data? Who gets access? How are decisions made about data? How do we resolve conflicts when definitions clash?
Okay, so if governance is the OS, who are the people running it? You mentioned accountability. How do we make sure this isn't just another task dumped onto an already swamped IT department? Because that happens a lot.
That is the critical strategic shift right there. Effective governance absolutely requires establishing clear data stewards. And here's the key part. These stewards must be business leaders, not IT staff.
Business leaders.
Right.
VPs.
Yes. For example, the steward for customer master data might be the VP of marketing operations, or maybe the head of sales ops. The steward for financial transaction data might be the controller or someone senior in finance. They are made formally accountable for the accuracy, the completeness, the definition, and the appropriate use of those critical data elements within their domain.
Okay, I can practically hear the pushback already. Wait, I'm already the VP of marketing, juggling a million things. Now you want me to be a data steward too. How do you realistically implement that kind of accountability?
Look, it's not easy. The reality is it requires a clear executive mandate from the very top.
Yeah.
And structural support,
Meaning?
meaning stewards need dedicated time allocated for this role. They need specific training on governance principles and tools. They need crystal clear expectations about what success looks like. Their performance might even be partly measured by improvements in the quality metrics for their data domain.
So it needs teeth.
It needs teeth. If you don't truly empower them, give them the time, and measure their success in this role, they'll inevitably default back to their primary day job, and governance will flounder. Honestly, overcoming the political challenge of assigning real accountability to already busy business leaders is probably the single biggest hurdle in implementing effective governance.
Okay, so assuming you get the accountability piece right with the stewards, then you need to measure the quality itself. What are those key dimensions of quality we need to be tracking systematically?
Right, you need to define and track probably the 6 critical metrics that really determine if data is usable and trustworthy.
Okay.
First, accuracy. Does the data actually reflect the real-world thing it's supposed to represent? Is the address correct? Second, completeness. Is all the necessary information actually there? Or is the phone number field blank half the time?
Common problem.
Very common. Third, consistency. Is the data uniform across different systems? Is the customer's name spelled the same way in the CRM, the billing system, and the support system? Or is the address format totally different? Fourth, timeliness. Is the data fresh enough for the decision you need to make right now? Yesterday's stock price is pretty useless for high-frequency trading, right? Fifth, validity. Does the data conform to the defined rules and formats? Does a date field actually contain a valid date, or is it just garbage text? And sixth, uniqueness. Are there duplicates? Especially for things like customer or products. A single unified view is impossible if you have 5 different records for the same customer.
So by measuring these 6 things systematically and holding the stewards accountable for improving them, you move from just randomly fixing errors to actually making strategic improvements in data trustworthiness.
Precisely, that's the goal. Now, pillar 2 in the framework is architecture. This is the tech platform, the infrastructure. We're going to hold off on the deep dive into, data lakes versus warehouses versus lakehouses until section 4. But let's just be clear here. The architecture is the foundational plumbing. It's what actually allows those governance policies and quality rules we just talked about to be technically enforced. It enables pillar 1.
Understood. Architecture enables governance and quality. Let's jump to pillar 3 then, analytics and insights. This is where the rubber meets the road, right? Where the data asset finally starts creating tangible value.
This is the output factory, exactly. And this is also where we see probably the most common strategic mistake. Organizations get excited and they try to rush straight to the top of the analytical maturity curve. They want AI and complex predictions now.
Before they've mastered the basics.
Exactly. You absolutely have to walk before you can run. You need to build maturity step by step.
And that walk starts with just understanding what happened. Descriptive analytics.
Stage 1 is descriptive analytics. Simply answering what happened. This is your foundational business intelligence, BI, your basic reporting, your dashboards, your KPIs. And frankly, if you can't even get this right, if 2 different departments consistently report 2 different numbers for the same metric, like quarterly revenue,
Which happens.
then the entire data initiative will lose credibility right out of the gate. Trust evaporates. So, nail descriptive first. Then stage 2 is diagnostic analytics. Answering, okay, why did it happen?
Getting beyond the what's to the why.
Right. This moves past just reporting the numbers to understanding causality, finding the drivers. If sales dipped last quarter, diagnostic analytics helps you figure out why. Was it a specific product underperforming? Was it a particular region? Did a competitor launch a disruptive campaign? It adds context.
Okay, makes sense. Then we move from explanation to looking forward.
Stage 3 is predictive analytics. Answering what is likely to happen next. This is the realm of machine learning, statistical modeling, forecasting.
Like predicting customer churn.
Predicting customer churn, anticipating when a piece of equipment might fail, forecasting future inventory needs based on past trends and seasonality. This stage requires significantly higher quality historical data and obviously more sophisticated modeling skills.
And the peak of the curve.
Yeah.
The highest level of maturity where the value potential is greatest.
That's stage 4, prescriptive analytics. This answers the ultimate question. So what should we do about it?
Giving recommendation.
Exactly. It goes beyond prediction to actually recommend optimal actions, and often it aims to automate those decisions. Should we offer customer A a 10% discount right now to prevent them from churning based on their profile? Or is 5% enough? Should the manufacturing robot adjust its speed by exactly 0.5% right now to maximize throughput based on current sensor readings?
That requires a huge amount of organizational trust, doesn't it? Letting systems make operational decisions.
Absolutely massive. You only get to prescriptive analytics when the business fundamentally trusts the data, the models, and the governance framework underpinning it all.
Which brings us very neatly to Pillar 4, people and culture. The source material really highlights this one. It calls it the most complex challenge of the whole thing because data transformation isn't really about tech. It's ultimately about people changing how they work.
That is spot on. Technology, honestly, is relatively easy to buy. Changing deeply ingrained human habits, workflows, and power structures, that's incredibly hard.
So what does a successful data culture actually look like? What are its characteristics?
Well, first and foremost, it starts with intellectual humility, actually.
Humility. How so?
It values curiosity over certainty. It means leaders actively encourage people to test assumptions, to question the status quo with data, rather than just relying on gut feelings or the way we've always done it.
Okay.
And crucially, you have to actively dismantle the power of the HIPPO,
The HIPPO.
the highest paid person's opinion.
All right.
That phenomenon can kill data initiatives instantly. If the CEO or a senior exec consistently overrides data-driven findings simply because they feel it's wrong or it contradicts their intuition, well, why would anyone bother doing careful analysis next time? The incentive is gone.
So leadership absolutely has to model the behavior they want to see, walk the talk. What else? Accessibility.
Yes, the culture must champion accessibility. Data can't be this precious resource locked away in an IT fortress, requiring complex rituals and long waits to access.
Democratization of data.
To a degree, yes, within clear governance boundaries, of course. Business users, the marketers, the finance pros, the people on the front lines interacting with customers, they need to be able to safely and easily access the information that's relevant to their roles to do their jobs better. This requires investing in user-friendly self-service tools and having those clear governance policies that enable access responsibly rather than just restricting it by default.
And the ultimate end goal, the holy grail of data culture.
Evidence-based decision-making. As a cultural norm, it means every significant meeting, every important decision, ideally starts with a review of the relevant data. Not with opinions, not with anecdotes, not with guesswork. Building this culture requires managers to foster psychological safety, making it okay to challenge assumptions, even senior ones, as long as you bring the data to back it up. Rewarding evidence, not just opinions.
Okay, that covers people and culture. Finally, Pillar 5, use cases and value realization. This seems to be the pillar that connects everything else back to the original strategic purpose, right? Ensuring all this effort actually delivers something.
Precisely. The authors have a great line. Strategy without execution is basically just hallucination.
Huh, like that.
Yeah. Every single data effort, every project, every analysis must be explicitly tethered to solving a high-value, measurable, and realistically achievable business problem. And it needs clear, active executive sponsorship. This pillar forces you relentlessly to focus on outcomes, not just outputs.
Okay, let's nail that distinction again because it's so critical, especially when you're talking to the C-suite, trying to justify investment. Output versus outcome.
Right. An output is what the technical team delivers. It's a thing. We built a new data pipeline. We deployed a machine learning model with 85% predictive accuracy.
Things the CFO doesn't necessarily care about directly.
Exactly. It means very little to the CFO or CEO in itself. An outcome, however, is the tangible business impact that output enabled. That new pipeline allowed us to process customer transactions 50% faster, which directly reduced our operational costs by $200,000 this quarter. Or, that predictive model helped us reduce customer churn by 3%, retaining $5 million in annual recurring revenue. That's the language of value.
So you have to rigorously track, measure, and report those outcomes, the revenue gained, the costs cut, the risks avoided.
Absolutely. That is the only way you can justify the initial investment in all these pillars and, crucially, secure the ongoing funding needed to sustain and grow the capability over time. It closes the loop back to business value.
Okay, securing that long-term funding, getting the C-suite on board, it really requires speaking their language, doesn't it? The language of business outcomes we just discussed. Data professionals often struggle here, trying to translate technical needs into executive vision. How does a strategic leader build that compelling business case effectively?
You have to become a translator, essentially. Perform immediate tactical translation. If your team says, we need funding for a modern data lakehouse architecture, you absolutely do not go to the CFO with that.
Right, they'll glaze over.
Completely. Instead, you say, we need to invest in the foundational capability that will allow us to reduce our fraud losses by an estimated $4 million annually through real-time detection. This proposed architecture enables that specific outcome. See the difference?
Connect the tech directly to the money.
Always. You have to explicitly link technical investments, like enhancing data lineage capabilities, to the outcomes the C-suite actually cares about, like mitigating regulatory risk and avoiding potential multi-million-dollar non-compliance fines. They primarily speak the language of revenue, cost, and risk. So you have to translate into those terms.
And we need to quantify that value with, well, extreme specificity, right?
Sure.
What were those 4 categories of value again, and how do we make the examples really concrete and believable?
Right. The 4 main categories are your strategic levers for justifying investment. 1. Revenue generation. Don't just say increase revenue. Be specific. Example. Implementing these new personalization models is projected to increase the average customer lifetime value by $15 within 12 months.
Measurable.
Measurable. 2. Cost reduction. Again, be specific. Example. Automating 40% of the current manual report generation process in finance will reduce our headcount requirement by 2 full-time equivalents, saving the company $150,000 annually in operational expense.
Tangible savings.
Tangible. 3. Risk mitigation. Often involves compliance or security. Example. Implementing a single unified customer view will allow us to fully comply with the new KYC, Know Your Customer regulations, significantly reducing our exposure to potential non-compliance fines, estimated at up to $3 million.
Avoiding future pain.
Exactly.
Okay.
And 4, strategic positioning. This one can be a bit harder to quantify immediately, but it's crucial for long-term growth. Example, building this core data platform gives us the essential capability needed to launch 2 planned new data-driven product lines within the next 18 months, opening up new market opportunities.
Okay, so specific examples across those 4 categories. Now, to get that significant multi-year funding needed for real transformation, the business case usually needs a clear, realistic financial model, right? Often looking out 3 years. Why is that time frame important?
That 3-year ROI model framework is absolutely essential, mostly for managing expectations and showing a credible path to profitability. It acknowledges the reality that building strategic capability takes time, and value realization isn't instant.
It's not flipping a switch.
Definitely not. The model typically looks something like this. Year 0, implementation. This is the year of maximum cost. You're buying platforms, hiring key people, defining initial governance. Returns are minimal, maybe even 0. It's pure investment.
Setting the foundation.
Year 1, pilot value. Now you start deploying those first few high-value, quick-win use cases we talked about. You project modest returns here, maybe, say, 30% of the eventual long-term steady-state value. This is where you prove the concept works and start building organizational trust and momentum.
Showing early promise.
Year 2, scaling. As the platform matures, as your internal teams get more skilled, and as you roll out more use cases across different business units, the returns should accelerate rapidly. You might reach perhaps 70% of the full steady-state value in this year.
Value ramps up.
Year 3 plus steady state. By year 3 and beyond, you expect to achieve full value realization from the initial scope. The data organization is now hopefully operating efficiently, focusing on optimization, continuous improvement, and identifying the next wave of value creation.
That framework seems critical because it prevents the classic mistake of overpromising instant returns, which is just unrealistic for building a complex strategic capability like this.
Exactly. It shows financial discipline and manages expectations realistically. But look, the spreadsheet model is necessary, but it's not sufficient.
You need the political side, too.
You absolutely need political capital. Getting that executive buy-in requires finding a powerful executive sponsor. And the research is clear. Ideally, the sponsor should be a senior business leader, not the CIO or CTO.
Why a business leader specifically?
Because they need to viscerally feel the business pain your data strategy is solving. They need to own the outcome. And they need to have the authority and influence to break down the inevitable silos between different business units that often impede data sharing and collaboration. The IT leader sponsors the tech. The business leader sponsors the value.
Makes sense.
And crucially, don't wait for the big formal presentation to unveil your plan. You need to build a coalition of support before you walk into that room. socialize the ideas, gather input, address concerns proactively. By the time you formally ask for funding, the key decision makers should already be largely on board.
Pre-selling the idea.
Essentially, yes. Building consensus early.
Okay, now let's circle back to governance, but look at it through this lens of strategic leadership and enablement. You mentioned shifting governance away from being just a gatekeeper, the Department of No, towards being a facilitator, an enabler of safe, efficient, high-speed data use. How does that shift happen in practice?
The role of the Central Governance Council or body fundamentally changes. Instead of getting bogged down reviewing every single individual request for data access, which just creates bottlenecks and immense frustration.
The dreaded backlog.
The dreaded backlog? They focus on higher-level strategic tasks, setting clear policies based on risk, identifying systemic data risks across the enterprise, defining and promoting data standards. They create the clear, standardized processes and guardrails that allow most data use to happen quickly and safely without their direct intervention on every case.
Empowering others within a safe framework.
Precisely.
We need a practical example of how that balance works, enabling speed and agility while still managing risk effectively. Can you walk us through that retailer's tiered access model again? That seemed like a good illustration.
Yeah, it's a great example of risk-based governance in action. This retailer implemented a tiered access model specifically to accelerate self-service analytics and reporting while protecting sensitive data. They basically classified all their data assets into tiers based on sensitivity and the potential risk of misuse.
Okay, what were the tiers?
Tier 1 was public or aggregate data. This was non-sensitive stuff. High-level weekly sales trends across regions, public product specifications, maybe aggregated website traffic. Access to this. Granted instantly via self-service portals, zero manual approval needed. This immediately removed the governance bottleneck for the vast majority of low-risk, high-volume data requests.
Freeing up capacity.
Exactly. Tier 2 was internal or operational data. This was company confidential but didn't contain sensitive PII. Personally identifiable information. Think detailed inventory logs for a specific warehouse, department-level budget tracking, internal process metrics. Access here required a simple request, maybe automated logging of who accessed what, perhaps a quick review by the user's direct manager, but generally straightforward.
Still fairly light touch.
Relatively light touch. Tier 3 was restricted or regulated data. This was the really sensitive stuff. Detailed customer PII, individual transaction records, proprietary algorithms, sensitive financial results before public release. Access to Tier 3 data that required a full security review, explicit documented approval from the designated data steward for that specific data domain, and a clear documented justification for the business need. Much tighter controls.
So that system basically allows maybe 80% of the common data requests to flow quickly with minimal friction, while reserving the heavy-duty controls and human oversight for the critical 20% that carries significant business or regulatory risk. It makes governance feel more like a partner, not just a roadblock.
That's the goal. It creates clear, predictable pathways for accessing data, which builds trust and encourages usage.
Okay, finally, under strategic leadership, we need to think about organization design. Once you have the mandate, the funding, the governance approach, how should the actual data teams be structured? The source material strongly advocates for the federated model as often being the best fit for larger, complex organizations. Why that model?
Well, we've seen the inherent flaws in the extreme models, right? Purely centralized models where all data talent sits in one central team, offer economies of scale, consistent standards, clear career paths. But they often become slow, bureaucratic bottlenecks, completely disconnected from the urgent, day-to-day needs of the individual business units.
Ivory tower syndrome.
Exactly. On the other hand, purely decentralized models where each business unit hires its own analysts and data scientists offer deep business context and potentially faster response times for local needs. But they almost always lead to chaos. Massive duplication of effort, inconsistent standards and tools, fragmented talent pools, no economies of scale. Basically, data silos everywhere.
Right. So the federated model tries to get the best of both worlds. How's that hybrid structure actually work?
It is a hybrid approach, yes. Typically, you have a relatively small central data office or center of excellence, COE. This central body handles the core enterprise-wide capabilities, building and managing the common data platform, setting enterprise data standards and policies, leading the overall governance framework, handling large-scale data acquisition.
The foundations.
The foundations. But then this is the crucial part. The analysts, data scientists, maybe even data engineers who actually apply the data to solve specific business problems. They are embedded directly within the business domain teams.
So a data scientist physically sits with the marketing team, or an analyst works day-to-day within the supply chain group.
Exactly. They report primarily to that business unit for their daily work priorities.
Okay, but how do you keep that from just becoming decentralization again? How do you maintain standards and prevent those embedded folks from just doing their own thing?
That's where the clever mechanism comes in, the dual reporting relationship.
Dual reporting, how does that work?
It means the embedded analyst or data scientist reports functionally to their business unit leader. That leader sets their day-to-day priorities based on business needs. I need an analysis of campaign X this week, or help us optimize the supply chain route.
Okay, reporting to the business for tasks.
Right. But they also report administratively, or sometimes called a dotted line report, back to the Central Data Office, CDO or CUE.
Okay, and what's the purpose of that dotted line back to the center? Where does the inevitable organizational tension come in?
The tension is inherent and actually healthy if managed well. The business leader wants immediate results focused solely on their domain's problems. The Central Data Office, through that administrative reporting line, ensures adherence to enterprise standards, promotes best practices, enforces data quality rules, manages career development and training for the analytical talent across the whole company.
So, the CDO provides the guardrails.
Exactly. The CDO manages their career progression, ensures compensation is consistent across similar roles, provides access to specialized training, and critically enforces those enterprise standards for things like data modeling, documentation, and code quality.
So, if an embedded analyst just quickly hacks something together for marketing to solve an immediate problem,
The CDO, through that dotted line relationship and associated processes like code reviews or model validation, can step in and say, okay, that's a good start, but to meet our enterprise quality standards and ensure this doesn't create downstream problems, you need to refine it this way or document it properly. It provides the necessary check and balance.
it balances the business unit's need for speed and relevance with the enterprise's need for consistency, quality, and scalability.
That's the core idea. It's the structure designed to navigate that inherent tension productively.
All right, we've laid out the strategy, the leadership alignment, the organizational structure. Now we need to get into the actual mechanics, the implementation details, starting with the technical architecture pillar 2, which we parked earlier.
Right, the plumbing.
Modern data platforms are usually defined by these three terms: the data lake, the data warehouse, and now the data lakehouse. What are they, and what are their strategic roles? How do they fit together?
Okay, so let's break it down historically a bit. The data warehouse was really the original standard for serious BI. Think highly structured data, typically relational, meticulously organized, and optimized for fast, reliable reporting and analysis. Great for traditional BI.
But it had limitations.
Big limitations.
Yeah.
Warehouses were often expensive, quite rigid, and notoriously bad at handling unstructured or semi-structured data, things like text documents, images, videos, social media feeds, sensor logs. You couldn't easily load that stuff into a traditional warehouse.
Okay, so along came the data lake.
Exactly. The data lake emerged, largely enabled by cheaper storage like Hadoop HDFS or Cloud Object Storage. The core strategy behind the lake was, frankly, simplicity and low cost, at least initially. The idea was just dump all your data structured, unstructured, semi-structured, raw, any format, into this one massive, cheap storage repository. Don't worry about defining schemas or cleaning it up front.
Store everything now, figure it out later.
That was the mantra. The promise were flexibility and avoiding the costly upfront modeling needed for a warehouse.
But the lake quickly got a bad reputation, didn't it? The infamous data swamp. Why did that happen?
Because fundamentally, it often lacked governance and management. If you just dump raw, uncurated data into a massive repository without defining structure, tracking quality, implementing security, or managing access effectively, well, it becomes a swamp. Nobody trusts the data, nobody can find what they need, different copies proliferate. It was often a strategic failure of management, not just a technology issue.
Which led to the next evolution, the lakehouse.
Precisely. The data lakehouse architecture emerged as an attempt to strategically combine the best attributes of both the warehouse and the lake. The idea is to keep the low-cost, flexible storage foundation of the data lake, often using open file formats like Parquet or Delta Lake on cloud storage, but overlay it with critical data management and governance features that were traditionally only found in the warehouse.
Okay, what are those critical features that sort of tame the swamp and make the lakehouse reliable?
The most critical ones are things like support for A-to-D transactions, atomicity, consistency, isolation, durability. These guarantee data reliability and consistency, especially when multiple users or processes are reading and writing data concurrently. That was a huge weakness of early data lake.
Right, preventing data corruption.
Exactly. Plus, the ability to enforce data schemas, implement data quality rules directly on the data in the lake, provide fine-grained security controls, and offer high-performance query engines similar to warehouses. Essentially, the Lakehouse aims to provide a single, unified platform where you can do everything from storing raw, messy data cost-effectively, right through to serving curated, high-performance BI reports and running advanced ML workloads, all on the same underlying data, reducing the need for complex, brittle ETL pipelines moving data between separate lake and warehouse systems.
So potentially simplifying the overall architecture quite a bit.
That's the promise. One unified system for most data needs.
Okay, architecturally, another key decision is about how the data actually flows through these systems. When do we need expensive, complex, real-time processing versus when can we stick with simpler, cheaper batch processing?
This decision absolutely must be driven by the actual business value, not just because real-time sounds cool. Batch processing, where you process data in chunks, maybe hourly or overnight, is simple, reliable, and much less expensive to build and operate. And it's perfectly acceptable, even optimal, for a huge number of workloads where near instantaneous data isn't actually required.
Like,
Daily financial reconciliation reports, complex risk models that run overnight, weekly sales summary dashboards. If the business only looks at or acts on the data once a day or once a week, why incur the significant cost and complexity of a real-time pipeline? Batch is fine.
but there's increasing pressure for immediacy in many areas, right?
There definitely is. Real-time processing, or near real-time streaming, becomes necessary for use cases where decisions need to be made based on data that is seconds or milliseconds old. Fraud detection is a classic one. You need to catch the fraudulent transaction as it happens, not hours later. Real-time personalization of a website based on a user's current clickstream. Continuous monitoring and alerting based on IoT sensor data from machinery, industrial control systems.
And when we talk about feeding these real-time pipelines, a term that often comes up is CDC, change data capture.
Yes, CDC is a crucial technology, especially for getting data out of traditional operational databases like your order system or CRM into your analytical platform in near real time. Instead of constantly querying the entire database to see what's new, which is inefficient and puts load on the source system, CDC techniques effectively tap into the database's transaction log to capture only the changes, inserts, updates, deletes as they happen, and then stream those changes immediately to the downstream systems like the Lakehouse or streaming applications.
So it's much more efficient for real-time data acquisition from operational systems.
Much more efficient, much lower latency. But again, you have to carefully weigh the cost and complexity of setting up and managing real-time CDC pipelines against the genuine, measurable business value derived from that immediacy. Don't do real-time just for the sake of it.
Okay, moving from the architecture to the actual integrity of the data itself. Chapter 12 really hammers home that data quality isn't a one-off cleanup project. It's a continuous operational discipline. And critically, we can't just keep fixing the symptoms, the bad data entries. We have to dig deeper and analyze the root causes. How do we apply something like the 5 whys technique to do that rigorously?
This is so important for breaking the cycle of constantly fixing the same recurring data problems. The 5 whys is a simple but powerful technique to systematically drill down past the obvious symptom to uncover the underlying systemic failure. Let's walk through a common scenario. A critical monthly financial report is delayed, again because a key data field feeding into it was found to be incorrect at the last minute.
Okay, familiar pain points. So why was the report delayed? The first why?
Because the aggregated revenue calculation was wrong due to an incorrect price entry for a high-volume product.
Okay, why was the price entry wrong? The second why?
Because the data entry person manually inputting the price update accidentally chose the wrong currency code from a drop-down list. There were 2 codes that looked very similar, say USD and USN.
Simple human error. Why did the system allow the inputter to choose a similar-looking, incorrect option for that product? The third why?
Because the source data entry system, maybe an old ERP module, was poorly designed. It lacked specific validation rules or cross-checks to prevent that particular invalid currency code from being associated with that product line. The drop-down just showed all possible codes.
A system design flaw. Why did the system lack those adequate validation checks? The fourth why.
Because when that ERP module was originally implemented 5 years ago, the project team prioritized speed of deployment and minimizing customization costs over implementing rigorous data validation rules up front. Nobody thoroughly validated the end-to-end data entry process from a quality perspective back then.
Cutting corners early on. Why were speed and cost prioritized over data rigor back then? The fifth why.
Because fundamentally, there was no designated enterprise-wide data steward accountable for defining and enforcing data quality standards for critical elements like product price or currency code during system implementations. And maybe the IT project team itself lacked the specific training, mandate, or business context to push for those stricter quality controls against pressure to deliver quickly and cheaply.
So that fifth why gets us there. It reveals the systemic organizational failure, a lack of clear governance, missing accountability, no steward, maybe inadequate training or process standards, not just a one-off data entry mistake by one person.
Exactly. And therefore, the real fix isn't just correcting that one bad price entry, it's organizational. Appointing a steward, updating the system validation rules, improving training, implementing better processes for future system changes. Addressing the root cause prevents the same error from happening over and over again.
Makes sense. And because quality isn't a one-time project, you also need continuous monitoring, right?
Absolutely essential. You can't just clean data once and assume it stays clean. You need automated data quality checks embedded directly into your data pipelines, constantly monitoring the health of critical data elements against predefined rules, like completeness, validity, range checks, uniqueness.
And alerting when things go wrong.
Yes, but use tiered alerting. Don't overwhelm people. For example, if a critical data element in a pipeline feeding a regulatory report fails a key validation check, maybe send an immediate high-priority alert to the on-call operations team to fix it urgently. But if, say, a non-critical descriptive field experiences a minor dip in completeness, maybe drops from 98% to 96% complete, perhaps just include that in a daily or weekly summary digest sent to the relevant data steward for proactive review and management. Match the alert severity to the business impact.
So continuous monitoring with intelligent alerting keeps data health confidently maintained without creating alert fatigue.
That's the idea. Proactive, automated, risk-based quality management.
Okay, finally, in implementation, we absolutely have to embed security and compliance right from the start. Security by design. What are the foundational principles that need to guide this?
3 core principles really underpin modern data security strategy. First is defense in depth. This means layering multiple security controls. Don't rely on just one thing like a perimeter firewall. Assume that one layer might fail. So you add other controls like network segmentation, strong authentication, encryption of data at rest, and in transit, intrusion detection systems. If one control is breached, others are still there to protect the data.
Multiple barriers.
Multiple barriers. Second is the principle of least privilege. This is fundamental. Users, applications, systems, they should only be granted the absolute minimum level of access and permissions required to perform their specific, legitimate job function. Nothing more. Don't give everyone administrator rights just in case. This minimizes the potential damage if an account is compromised or misused.
Only give keys to the rooms they actually need to be in.
Perfect analogy. And third, and increasingly critical in today's complex environments, is zero trust architecture. This is a shift in mindset. You essentially assume that no user or device, whether they are inside or outside your network perimeter, is inherently trustworthy. Therefore, every single access request must be explicitly authenticated, authorized, and continuously verified based on multiple context factors before granting access to a resource. Trust is never assumed based on location alone.
Verify everything, always.
Pretty much. Assume breach, verify explicitly.
Now, applying those principles effectively requires understanding how sensitive different types of data actually are. Which brings us to data classification frameworks. Why are these necessary?
Because you simply cannot and should not try to secure all data equally. It's inefficient and incredibly expensive. You must categorize your data based on its sensitivity and the potential impact if it were leaked or compromised. A common framework might use tiers like public, data intended for public consumption, minimal security needed. Internal, data for internal use, not highly sensitive but not public, e.g. internal memos, general project info, requires basic access controls. Confidential, sensitive business data that could cause harm if disclosed, e.g. business plans, contracts, non-public financial info, requires stronger controls like encryption, stricter access management. Restricted, the most sensitive category, often including regulated data like customer PII, personally identifiable information, health records, PHI, credit card data, PCI, or critical intellectual property. This requires the highest level of security controls, mandatory end-to-end encryption, multi-factor authentication for any access, detailed access logging and monitoring, strict data masking, or anonymization where possible.
So you classify the data first, then you apply the appropriate level of security controls based on that classification level, matching the protection to the risk.
Exactly. It allows you to focus your security resources where they are needed most.
And when we talk about specific regulatory demands, especially things like GDPR in Europe or CCPA in California, the challenge often boils down to having the right technical capabilities in place, not just understanding the legal text, right?
That's absolutely true. Compliance isn't just a legal or policy issue. It's deeply intertwined with your data architecture, governance, and quality capabilities. Take GDPR, General Data Protection Regulation. It grants individuals rights like the right to erasure, the right to be forgotten, and the right to access, getting a copy of their data. Or CCPA, California Consumer Privacy Act, which grants consumers the right to opt out of the sale or sharing of their personal information.
How does that translate technically?
Well, imagine a customer invokes their right to erasure under GDPR. To fulfill that request legally and completely, you must be able to accurately locate every single instance of that customer's personal data across all your systems. CRM, billing, marketing databases, analytics platforms, backups, everywhere, and then reliably delete it or anonymize it.
That sounds incredibly difficult without the right foundation.
It's practically impossible without robust data mapping and lineage tracking. You need technology and processes that show you exactly where specific types of data originated, how they have flowed through your various systems, where they are currently stored, and how they are being used. Without that detailed map and lineage, you simply cannot comply reliably with these kinds of individual rights requests. So yes, governance, quality, architecture, they all converge and become essential technical enablers for meeting modern privacy regulations.
Okay, we've built the strategic foundation, aligned leadership, designed the organization, and tackled the core implementation mechanics of architecture, quality, and security. The final, and arguably most important challenge, is actually converting all those carefully managed data assets and insights into genuine, profitable actions.
Right, data sitting in a dashboard is interesting, but it doesn't inherently create value.
And the material strongly emphasizes that the maximum value is typically unlocked when an organization successfully transitions up the maturity curve to prescriptive analytics. Remind us why that stage is so powerful.
Because prescriptive analytics moves beyond just predicting what might happen, to actively recommending the optimal action to take in response, often aiming to automate that action. It closes the loop between insight and execution.
But, and this is a big but, prescriptive analytics only delivers that potential value if the organization actually acts on the recommendations consistently, right? How do you bridge that gap between the recommendation and the real-world action?
That gap, the friction between getting an insight and actually doing something about it, is often the biggest barrier to value realization. The most effective way the research highlights to overcome this is through embedded analytics.
Okay, explain that mechanism. What does embedding analytics actually look like in someone's daily workflow? How does it reduce that friction?
It means quite literally inserting the data insight, the prediction, or the prescription directly into the software application or tool that the user is already using to make their decision or take their action.
So instead of them having to go look at a separate dashboard or report.
Exactly. Take a call center agent talking to a customer. Instead of needing to switch to a separate analytics tool to see the customer's churn risk score, an embedded analytic might display that risk score, maybe high, medium, low, and perhaps even a prescriptive recommendation like offer retention discount package B directly within the agent's main CRM screen right next to the customer's contact details.
So it's right there, in context, at the moment they need it.
Precisely. Or consider a supply chain planner using their planning software. An embedded analytic could highlight a forecasted stockout risk for a particular product in a specific warehouse and recommend the optimal inventory transfer from another location, all within the same planning interface they use every day. It dramatically reduces the mental effort and time delay required to translate the insight into action. It forces the insight into the decision-making moment.
Makes perfect sense. Frictionless insight delivery. Now, we know this kind of data transformation is a long journey measured in years. But to sustain momentum, to keep executives and teams bought in, you need those early wins. You need to show progress quickly. What are the key criteria for selecting those critical quick win pilot projects?
Choosing the right initial projects is absolutely crucial for building credibility and momentum. The research suggests quick wins must ideally meet 4 specific criteria. 1, high business value. It has to address a real, recognized pain point and have a clear, preferably quantifiable ROI. Solving a trivial problem doesn't build much political capital. 2, feasibility. It must be realistically achievable with the organization's current capabilities, data technology, and skills. Don't pick a first project that requires a massive 6-month platform build or hiring skills you don't have yet. Start with what you can do now. 3, measurability. You need to be able to clearly define success metrics upfront and measure the impact relatively quickly, ideally within weeks or a few months, not a year. You need to prove the value fast. 4, executive sponsorship. And crucially, like any important project, it needs a visible, active executive sponsor who cares about the outcome and can help remove roadblocks.
Okay, high value, feasible, measurable, sponsored. Can you give us a concrete example of a proven quick win scenario that typically meets those criteria and delivers that visible impact quickly?
A classic, often highly effective one is the executive dashboard redesign.
Redesigning dashboards. Seems simple, but why is it effective?
Because senior executives are often incredibly frustrated by their existing dashboards. They might get dozens of reports, 50 contradictory metrics crammed onto a single confusing screen, data they don't trust. They know they need data, but they feel overwhelmed and underserved by what they currently get.
So there's a clear pain point and sponsorship potential.
Exactly. A small, focused data team can work directly with that frustrated executive sponsor, maybe the CEO, CFO, or a business unit head, to identify the 3 to 5 truly critical KPIs that actually drive their key decisions. Then, the team builds a clean, simple, visually appealing, and rigorously validated dashboard, focusing only on those vital few metrics, ensuring the data is trustworthy and easy to understand.
How is that feasible and measurable quickly?
It's usually highly feasible because it often leverages existing data sources, just presenting them better, and uses standard BI tools. And the impact is highly measurable and visible. The executive immediately gets clearer insights they trust. This can often be accomplished in just 4 to 8 weeks. It delivers immediate, tangible value right at the top, which builds immense trust and buy-in for future, more complex data initiatives. It's a fantastic way to demonstrate capability quickly.
Great example, but
Sure.
the moment you achieve that first quick win, the moment you start changing how things are done based on data, you inevitably run into the human side of change management.
Why do people often resist these kinds of improvements even when the data seems to clearly show a better way forward? It seems irrational sometimes.
It often seems irrational from the outside, but the resistance is frequently quite rational from the individual's perspective. Think about it. Employees who have spent years, maybe decades, honing their intuition, their experience-based judgment, their gut feel in a particular domain.
Their expertise. Exactly. They may genuinely fear that this new emphasis on data will diminish their perceived expertise, maybe make their hard-won skills obsolete, or worse, potentially expose past decisions that, in hindsight, look suboptimal when viewed through the lens of data. That's threatening.
So it's about fear of losing influence or status.
Often, yes. Fear of losing influence, fear of being exposed, fear of the unknown, or just plain transformation fatigue. Oh, great, another major initiative. You have to acknowledge and address these very real human factors.
So how do you manage that resistance and sustain momentum?
It requires a multi-pronged approach. First, you have to keep continuously delivering tangible value, string those quick wins together, showing people repeatedly how data can actually help them do their jobs better, make their work easier, or achieve better results, rather than just threatening them. Second, you absolutely need sustained, visible commitment from senior leadership. Executives need to consistently communicate the why behind the transformation and model the desired data-driven behaviors themselves. And third, you need to actively manage the change, communicate frequently, provide training and support, celebrate successes, and maybe even refresh the messaging periodically to keep it from getting stale, and remind everyone of the ongoing benefits and necessity of the transformation. It's a continuous effort.
Okay, so as we wrap up this strategic roadmap, let's look ahead briefly. The field of data and analytics is constantly evolving. What are some of the key emerging trends mentioned in the source material that organizations really need to be preparing for now to stay ahead?
There are 3 big ones highlighted. First is the accelerating convergence of AI and data, particularly with generative AI.
Like ChatGPT and similar models.
Exactly. These models offer massive new possibilities for things like internal knowledge discovery, automating content creation, enhancing decision support. But, and this is critical, they require incredibly clean, well-governed, accurately mapped, and easily accessible internal data to be trained effectively and safely, especially for enterprise-specific tasks. So getting your core data foundation right, pillars 1, 2, 4, becomes even more critical to actually leverage these powerful AI tools responsibly. Your data strategy is becoming your AI strategy.
Interesting. Data foundation enables AI. What's the second trend?
The second is the continued relentless push towards faster decision velocity, which means the increasing necessity of real-time data capabilities. As customer expectations for immediate responses grow, as market cycles compress, more and more business use cases from dynamic pricing and personalized offers to real-time supply chain adjustments and fraud detection will demand sophisticated, reliable streaming data architectures. Batch processing won't cut it for competitive differentiation in many areas going forward.
So investing in streaming capabilities becomes more strategic. And the third trend, it's about how we organize.
Yes, the third is the rising importance, especially in very large, complex, diversified organizations, of the data mesh organizational and architectural model.
Data mesh, what's the core idea there?
Instead of the traditional approach of trying to centralize all enterprise data assets into one monolithic data lake or warehouse managed by a central team, which often becomes a bottleneck, as we discussed.
Right.
The data mesh advocates for a more decentralized approach based on business domains. In a mesh, individual domain teams, like finance or marketing or logistics, take full ownership of the data they generate and understand best. They become responsible for transforming, governing, and serving their data as a high-quality, easily discoverable, trustworthy data product that other domains can then consume autonomously via self-service platforms.
So treating data as a product owned by the domain experts.
Exactly, with central enablement of the platform and standards, but decentralized ownership and delivery of the data products themselves. It aims to radically improve scalability, agility, and the relevance of data by pushing ownership closer to the business context. It's a significant paradigm shift for large enterprises.
Okay, so AI convergence, real-time demands, and potentially data mesh for large orgs. Given this complex and rapidly evolving landscape, what's the core preparation strategy you'd recommend for our listener, based on the book's advice? How do you build a strategy that lasts?
The single most important thing is to ensure your strategy is fundamentally adaptive. Recognize that the specific technologies you choose today will change, the market will shift. So you must invest in flexible foundations. That means things like modular, open architectures that allow you to swap out components like a specific database or BI tool without having to rebuild everything from scratch. Avoid vendor lock-in where possible.
Build for change.
Build for change. And just as importantly, dedicate specific budget and, crucially, time for continuous learning for your data and analytics teams. Implement a discipline, maybe like maintaining an internal technology radar, to constantly track, experiment with, evaluate, and potentially adopt emerging tools and techniques. You need to be continuously building the skills and capabilities needed for whatever comes next. Adaptability in architecture and people is key. #outro.
Okay, so if we had to boil down the single most critical lesson, the core takeaway, gleaned from all this incredibly rich source material, it seems crystal clear, doesn't it? Building a truly successful, sustainable data strategy is overwhelmingly an organizational and a cultural challenge first.
Absolutely.
And only secondarily a technical challenge.
100%. Look, the specific technology platform you deploy today, it'll likely be outdated, maybe even obsolete in 5 years, maybe less. But the real lasting legacy of a successful data transformation isn't the tech stack. It's the fundamental culture change you managed to create.
How people think differently.
How people think, how they make decisions, how they collaborate using evidence. That's the prize. And getting there. Well, the path to true data maturity is long. It's measured in years, not months. Success isn't achieved by crafting some theoretically perfect initial plan on day one.
No silver bullets.
No silver bullets. Success comes through persistence, through relentless, transparent communication, and through continuous adaptation, being willing to learn, especially from the inevitable failures and setbacks along the way, and adjusting course accordingly. Blameless postmortems are key.
That persistence, that journey, it has to start somewhere, right now. The resource actually provides a very tangible 30, 60, 90-day plan framework for getting started. So what is that essential, personalized first step that you, our listeners, should take based on this deep dive?
The advice is unequivocal. The first 30 days must be almost entirely dedicated to intensive listening and learning. Don't jump to designing solutions or choosing technology yet.
Resist the urge to build.
Resist the urge. Instead, go out and interview every key stakeholder you can identify. Talk to the executive sponsor, sure, but also talk to middle managers. Talk to the frontline employees who actually deal with the data day in and day out. Understand their current pain points deeply. What are their specific frustrations with data quality or accessibility? What are their most pressing immediate priorities that data could potentially help with? You absolutely must ground your nascent strategy in that comprehensive, unfiltered organizational reality first.
Listen first. Understand the real problems. Then strategize.
Exactly. Take those invaluable insights you gather in those first 30 days, and then you can start to build something truly remarkable, something that actually solves real problems and delivers lasting value. Go build it.